Deployments are a critical aspect of the software development lifecycle, ensuring that code changes are delivered to production environments efficiently and reliably. In the context of DevOps, deployments are automated processes that move code from development through various stages of testing and finally to production. This ensures consistency, reduces human error, and speeds up the release cycle. Understanding how to design and implement deployments is essential for maintaining high quality software and achieving continuous delivery. In DevOps, deployments bridge the gap between development and operations. They ensure that new features, bug fixes, and updates are delivered to users seamlessly. Deployments are automated to minimize downtime and reduce the risk of errors. They are also designed to be repeatable and consistent, ensuring that the same process is followed every time code is moved to production. This consistency is crucial for maintaining the stability and reliability of the software. There are several types of deployments, each with its own use cases and benefits. Blue-green deployments involve running two identical production environments, allowing for seamless switching between them. Canary deployments release changes to a small subset of users before rolling them out to the entire user base. Rolling deployments gradually replace instances of the previous version with the new version. Each type of deployment has its own advantages and is chosen based on the specific needs of the application and the organization. Designing a deployment pipeline involves defining the stages and steps that code must go through before reaching production. This includes building the code, running automated tests, and deploying to staging environments. The pipeline should be designed to catch issues early and ensure that only high-quality code reaches production. It should also be flexible enough to accommodate different types of deployments and be easily maintainable. A well-designed pipeline is crucial for achieving continuous delivery and improving the overall efficiency of the development process. Implementing a deployment pipeline involves setting up the necessary tools and infrastructure to automate the deployment process. This includes configuring build servers, setting up automated testing frameworks, and integrating with version control systems. The pipeline should be monitored and maintained to ensure that it continues to function correctly and efficiently. Implementing a deployment pipeline requires collaboration between development and operations teams to ensure that all aspects of the deployment process are covered. Continuous integration, CI, and continuous deployment, CD, are key practices in DevOps that ensure code changes are automatically built, tested, and deployed. CI involves automatically integrating code changes into a shared repository and running automated tests to catch issues early. CD extends this by automatically deploying code changes to production once they pass all tests. Together, CI and CD enable faster and more reliable releases, reducing the time it takes to deliver new features and fixes to users. There are several tools available for automating deployments, each with its own features and benefits. Jenkins, Azure DevOps, and GitLab CI/CD are popular choices for setting up deployment pipelines. These tools provide a range of features, including automated builds, testing, and deployment, as well as integration with various version control systems and cloud providers. Choosing the right tool depends on the specific needs of the organization and the complexity of the deployment process. Monitoring and logging are essential components of the deployment process, providing visibility into the health and performance of the application. Monitoring tools track key metrics such as response times, error rates, and resource usage, allowing teams to identify and address issues quickly. Logging provides detailed information about the application's behavior, helping to diagnose and troubleshoot problems. Together, monitoring and logging ensure that deployments are successful and that any issues are detected and resolved promptly. Despite best efforts, deployments can sometimes fail, making rollback strategies essential. A rollback strategy involves reverting the application to a previous stable state in case of issues. This can be achieved through various methods, such as maintaining backups, using version control to revert code changes, or leveraging deployment tools that support rollback functionality. Having a well-defined rollback strategy ensures that issues can be quickly addressed, minimizing downtime and impact on users. Security is a critical aspect of the deployment process, ensuring that code changes do not introduce vulnerabilities. This involves implementing security best practices, such as code scanning, vulnerability assessments, and secure configuration management. Additionally, access controls should be in place to ensure that only authorized personnel can deploy code to production. By incorporating security into the deployment process, organizations can protect their applications and data from potential threats. To illustrate the concepts discussed, let's look at a case study of a successful deployment. Company X implemented a blue-green deployment strategy to minimize downtime and ensure a smooth transition between versions. They used Jenkins for their deployment pipeline, integrating automated tests and monitoring tools to catch issues early. By following best practices and continuously improving their process, they achieved a high level of reliability and efficiency in their deployments, resulting in faster release cycles and improved user satisfaction. Deployments can present various challenges, such as managing dependencies, ensuring compatibility, and handling large-scale rollouts. To address these challenges, organizations can adopt practices such as containerization, which isolates dependencies and ensures consistency across environments. Additionally, using feature flags allows for controlled rollouts and easy rollback if issues arise. By identifying potential challenges and implementing appropriate solutions, organizations can improve the reliability and efficiency of their deployment process. The field of deployments is constantly evolving, with new trends and technologies emerging. One such trend is the increasing use of AI and machine learning to optimize deployment processes and predict potential issues. Another trend is the adoption of serverless architectures, which simplify deployments by abstracting away infrastructure management. As these and other trends continue to develop, organizations must stay informed and adapt their deployment strategies to remain competitive and efficient. In conclusion, designing and implementing deployments is a critical aspect of the DevOps process, ensuring that code changes are delivered to production efficiently and reliably. By understanding the different types of deployments, designing effective pipelines, and implementing best practices, organizations can achieve continuous delivery and improve the overall quality of their software. Key best practices include automating the deployment process, incorporating monitoring and logging, and having a well-defined rollback strategy. By following these best practices, organizations can ensure successful deployments and deliver high-quality software to their users.